Hi there. We're going to have a recap on solving simultaneous equations, and that is going to lead us into a problem-solving task involving simultaneous equations. If we have a look up here at the visual question, you can see we have 3 Diet Cokes adding to 2 popcorns, totaling a price of £12. We also have 2 Diet Cokes adding to 2 popcorns, which gives us a total price of £10. This is sort of a visual representation of a simultaneous equation. If we were to go ahead and replace the Diet Coke image with a C and the popcorn image with a P, we could then present the image, the visual image then becomes an algebraic simultaneous equation. This idea of changing visual representations into algebraic simultaneous equations will be very useful when we come to do the problem-solving task a little bit later in the video. Okay, to start with though, we're going to do a recap on simultaneous equations. I put 3 simultaneous equations on the screen. If you'd like to pause the video and have a go at solving each of the simultaneous equations. Bronze is a slightly easier equation. You might see that from the fact we have the coefficient is the same already for here. We have 1y and 1y. I'm just going to highlight that to make that a little bit easier for you to see. So we've got this y and this y are already equal. Okay, we get a little bit more complex with silver and then a little bit more manipulation needing with gold. Okay, if you could pause the video now and have a go at solving each of the simultaneous equations. Okay, welcome back. I'm just going to put my solutions on the screen. So those are my solutions. If you got all 3 correct, that is fantastic. You can skip the next couple of minutes of the video or so. However, if you want to have a look at the complete working or you did make any small errors, I'm just going to talk through each of the questions very briefly. For the first question, the question looks like this. We already have 1y and 1y. So no manipulation is needed. I do not need to multiply either of the lines of algebra. Because I have 1y and 1y and I'm trying to remove a variable, I'm going to subtract the bottom line of algebra from the top line of algebra. That will allow me to remove the y variable because I'll end up with 0y. So once I do the subtract, 6x take away 4x leaves me with 2x's. 15 take away 11 leaves me with 4. If 2x's are 4 and we divide each side by 2, that's telling me that the value of x in these simultaneous equations must be 2. At this point, I'm halfway through the question. I then need to go ahead and solve for y. I choose one of the equations. Doesn't matter which one I choose because I'm going to get the same answer. So 6x plus y equals 15. But now I'm at an advantage because I already know that the variable x equals 2. I'm going to substitute the 2 into here where the x is placed in this equation. So you can see I've substituted the 2 into here. 6 times 2 is going to become 12. So I ended up with 12 plus y equaling 15. I subtracted 12 away from each side. You can see my negative 12 at this point because I've subtracted 12 from this side. At the same time, I've subtracted 12 from this side, telling me that the variable y must equal 3. And that is how I found my solution of x equaling 2, y equaling 3. For question 2, my question started like this. This time we did not have equal coefficients, so I had to manipulate at least one line of the algebra. One way of doing it is multiplying the bottom line to ensure that that 2x, when I times it by 2, it will become 4x. There is other ways of approaching this question. For example, you could have multiplied the bottom line by 3 to end up with 3y and 3y. However, I'm going to do it this way. So if I rewrite my question after the manipulation, my second line now looks like this. Everything has been times by 2. 4x plus 2y equals 34. Because I want to remove the variable x, I'm going to subtract to leave myself with 0x. 3y, take away 2y, leaves me with 1y. 27, take away 34, leaves me with negative 7. So I'm halfway through the question. The y variable is negative 7. I then choose an equation. I could have chosen any equation at the top of the screen here. I've chosen this one because it looks a bit simpler. I now know y is minus 7, so I'm going to substitute y minus 7 into this equation, and then I'm going to solve the equation to find x. I substituted in my negative 7. That left me with a two-step equation at this point. So I then added 7 to this side. I added 7 to this side. That's where the 24 comes from. Two x's were 24, so I divide each side by 2, telling me that the x variable must be 12, which is why my solution was x equals 12, y equals minus 7. Third and final question looked like this. This time the coefficients were a little bit more complex. We had to look at multiplying both lines of algebra. Again, there's other ways to approach this question. I've went with multiplying the top by 5 and the bottom by 2 in order to end up with 10x and 10x. So once I've manipulated the algebra, it looks like so. I'm going to do a subtract to end up with 0x. So that's going to leave me with 1y when I subtract the y values. And I'm also going to be left with 8 when I subtract 142 from 150. My y variable is 8. I'm going to take that y variable, substitute it back into one of the equations. Again, you could have chosen a different equation. You'd end up with the same answer. So from here, I substitute 8 in, multiply that by 3 to give me 24. At this point here, I have a two-step equation. I'm going to subtract 24 from this side. At the same time, subtracting 24 from this side results in a 6. If two x's are 6, 6 divided by 2 would tell me that the x variable is 3. There is my final solution. So hopefully we are up to speed with how to solve differing styles of simultaneous equations. Okay, so I'm going to set you away on a task just now. You've arrived at McDonald's, but there's been a power cut and the electrical menu is not working. However, you do find 12 receipts on the counter. You need to use your knowledge of simultaneous equations, a little bit on linear equations, and also a good problem-solving technique in order to work out all the prices from the main menu. I also want you to find the total order of 3 of the receipts which have been ink stained and therefore their total is not visible. Let me just get you started with that task. So here are the first 4 receipts. You can see that they have some information and some totals. Again, throughout this task, you have the ability to pause the video at any point. So the first 4 receipts look like that. The next 4 receipts look like that. Again, you can pause the video if needed. Notice this ink stain, which is a value you need to find. And the final 4 look like that. Again, pause the video when you require. Okay. So if I go back to this slide, just to give you a little hint as you approach the question, if I look at the first receipt and the 4th receipt, you'll see that I have 2 Big Macs and 3 chocolate milkshakes valuing £6.97. I have the same items on this receipt, Big Macs and chocolate milkshakes. So 3 Big Macs and 4 chocolate milkshakes are going to result in £9.96 for the price. Can you look at these 2 receipts and create a pair of simultaneous equations like we did on the very first slide of the video turning the visual representation into algebra? And then can you solve it to find the value of a Big Mac and also find the value of a chocolate milkshake? Could you apply that to other receipts within the problem-solving task? Again, I'm just going to give you a little bit of time on this slide in case you need a pause. And a little bit of time on this slide again in case you need to pause. Okay, so your task is you need to work through all 12 receipts and can you find the price for each individual item on the McDonald's menu here. Remembering also the little extension task of finding the value of the 3 ink-stained receipts. If you want to pause the video at this point or possibly rewind to see the receipts, and then I will talk you through my solution and show you my answers. Okay, welcome back. This was your full task. We are aiming to complete the McDonald's menu as well as finding the 3 differing totals from the ink-stained receipts. Your McDonald's menu should look like so. So by using various approaches, including simultaneous equations and linear equations, you should have been able to find the value of each item. So you can mark up your McDonald's menu using the answers on the screen. The final thing to talk about is the 3 values that we're missing. So we did have 3 receipts which had some information but did not have a total. So 4 fish or fillets and 4 chocolate milkshakes would have made a grand total of £8.56. This receipt here has 4 items. Once you start compiling the menu together and understanding some of the prices, you should be able to work out that 1 potato wedge, 1 chicken salad, 1 Big Mac, 1 McFlurry is going to give you a total of £6.74. The final ink stain would have been a value of £12.50, again using the values that you found for cheeseburgers and chicken nuggets. Okay, if you were able to recreate that McDonald's menu accurately and also find the 3 missing values, then that's brilliant. You've shown a very good understanding of solving simultaneous equations, but also putting a little bit of context with those simultaneous equations and also applying a problem-solving element.